Okay, so think about this for a sec. Venus, Mars, Earth, they're all, orbiting the same star, made from the same basic stuff.
Right, same neighborhood.
But they've ended up just wildly different, totally different places.
Yeah.
What made them go down such different paths? That's a huge question, isn't it? It gets right to the heart of, well, climate, water, and maybe even life out there.
Absolutely. And it's not just them. You've got places like Europa, too, with that ocean hidden under the ice.
Yeah,
Another whole can of worms, potentially.
exactly. So to dig into this whole habitability question, we've looked at some really interesting sources you shared.
Yeah, we've got a mix. There's a transcript from Danzoid's YouTube channel, which gives this great solar system climate overview.
Huh?
Then NASA Science News piece about Hubble, keeping an eye on Martian and Venusian weather patterns.
Ah, the interplanetary weather report.
Pretty much.
Yeah.
And to get into the nitty-gritty of actually doing stuff on Mars, we listened to NASA's Small Steps, Giant Leaps podcast, the one with Teddy Tsanetos.
Oh, the Ingenuity project manager. Yeah, that was fascinating.
Right. So it gives us that practical, on-the-ground, well, on-the-rotor perspective.
So we've got the big picture climate stuff, the sort of real-time weather checks from Hubble, and then this amazing deep dive into Ingenuity's story.
Exactly.
Our mission here, then, is to kind of connect those dots, pull out the key things we understand now about Mars and Venus, see how challenges like exploring Mars are tackled, Ingenuity being like the perfect example, and keep that bigger question about habitable places like Europa kind of simmering in the background.
Sounds like a plan. So where should we start? Hubble.
Yeah, let's start there. Hubble's been watching these planets for ages, right? What's it telling us?
Well, the really striking thing is just how different the reports are for Mars and Venus. Like, complete contrasts.
Okay, tell me more. What's happening on Mars according to Hubble?
Compared to when Viking visited back in the mid-70s,
Yeah.
Hubble's data suggests Mars is now. Well, it seems cooler, clearer, and definitely drier.
Drier. That's quite a change in, 40 or 50 years? Cosmically speaking, that's nothing?
It's surprisingly fast.
Yeah.
It raises questions about, Martian climate cycles. What's driving that trend?
Interesting. And Venus, is it getting drier too?
Nope. Completely different story. Venus's atmosphere looks like it's recovering from some really intense sulfuric acid rain.
Acid rain, wow.
Yeah, the thinking is it might be linked to a massive volcanic eruption, maybe sometime in the late 70s. So Mars is trending cooler, drier. Venus seems to be bouncing back from this big volcanic burp, basically.
They're heading in opposite directions.
Pretty much.
And that fits really well with something from the Danzoid video, doesn't it? This idea that, okay, Venus and Mars, maybe similar size, similar beginnings to Earth.
Right, the sister planets idea.
But their climates just went completely off the rails in different ways. Earth hit the jackpot, but our neighbors, not so much.
Exactly. It really highlights how delicate that habitable zone, that balance might be.
So connecting back to Danzoid's points on Mars, that super thin atmosphere is key, right?
Absolutely key. It's only, 1% of Earth's atmospheric density, which means under normal conditions today, liquid water just can't stick around on the surface. It would boil away or freeze almost instantly.
Even though we see all that evidence for past water, the riverbeds, the valleys.
Yeah, the geological signs are pretty clear. Water definitely flowed there once, but that thin atmosphere now just can't support it. It directly explains why Mars is, drier, like Hubble's seeing.
So Mars lost its atmospheric blanket, essentially.
You could put it that way. And Venus, of course, went the other way with a runaway greenhouse effect. It's a stark contrast, like Danzoid pointed out. Earth's sitting in this precarious middle ground.
Okay, so these big observations give us the current state. Mars, cool and dry. Venus, hot and recovering. But to really get a feel for exploring Mars, we need to talk about Ingenuity.
Yes, the little helicopter that could.
That interview with Teddy Tsanetos from the NASA podcast was just gold. He really lays out the challenges.
He really does.
Yeah.
It gives you such an appreciation for what they pulled off.
So what were the big hurdles he talked about? 3 main things, right?
Yeah, 3 huge ones. First, obviously, that super thin atmosphere we just mentioned, flying in 1% of Earth's air density.
How did he describe that? The analogy.
He said it's like trying to fly a helicopter here on Earth, but at 100,000 feet altitude.
Wow, okay. Basically almost no air to push against.
Exactly. Then, number 2, the cold. Mars gets incredibly cold, down to minus 90 Celsius in winter, minus 130 Fahrenheit. Just brutal for electronics and batteries.
Right, keeping things warm must have been a nightmare.
A huge challenge. And the third thing, the distance. The signal lag between Earth and Mars means you can't just joystick it in real time.
Ah, so it had to fly itself. Completely autonomous.
Totally autonomous. They'd send the flight plan up, and Ingenuity had to figure out the rest on its own. Navigate, react to conditions, everything.
Just incredible. And it wasn't supposed to last that long, was it?
Not at all. It was designed basically as a tech demo. 5 flights. That was the goal. Prove it could be done.
5 flights. And how many did it end up doing?
72. It
Yeah.
flew for almost 3 years. It just kept going and going. Soneto sounded so proud, and rightly so.
72 flights. That's unbelievable. A tech demo that became a marathon explorer.
Pretty much. It completely shattered expectations.
So what finally grounded it? That 72nd flight ended with a hard landing, you said.
Yeah, unfortunately. Flight 72 had a rough landing, and
Yeah.
Soneta's explained what they think happened. There's no absolute certainty,
That's
but
the likely cause.
it seems like the terrain was the culprit. They were flying near an area they nicknamed Valinor Hills, and apparently it was just really bland, featureless sand, basically.
Featureless. How does that cause a crash?
Well, Ingenuity navigated mostly by using a downward-looking camera to track features on the ground, combined with its inertial sensors, accelerometer, gyroscope, the stuff that senses motion and orientation.
Like in your phone, but way fancier.
Exactly.
Yeah.
But if the ground has no distinct features, the camera system gets confused. It can't accurately tell how it's moving or where it is. So then, instead has used another great analogy.
What was that?
Trying to fly a drone inside a completely white room, no visual cues, the navigation system gets lost.
Ah, okay, that makes sense. It literally couldn't see well enough to fly properly.
Seems like the most probable cause, yeah.
But even though it can't fly anymore, it's not totally dead, right?
Yeah.
Sonetos mentioned something interesting.
Right. This is pretty cool. The helicopter itself is damaged, can't fly.
Yeah.
But its main computer, its brain, is still perfectly healthy.
What does that mean?
It means it'll keep waking up every Martian day using its solar panels, and it can still record data, take pictures.
No way. So it's become like a stationary weather station.
Essentially, yeah. A long-term data logger. It'll provide this unique time-lapse record from that spot for years, potentially. Future explorers could retrieve that data.
Talk about exceeding the warranty. Even in failure, it's still contributing.
Absolutely. And the whole experience, the success, the challenges, even the final landing, it's all feeding directly into future plans.
How so? What are the big lessons learned that are being applied?
Well, the most direct application is for the Mars sample return mission.
Yeah.
The plan to bring Martian rocks back to Earth.
Yeah, a hugely ambitious plan.
Part of that involves using helicopters to retrieve the sample tubes left by the Perseverance rover. And the design for those helicopters is building directly on Ingenuity.
Okay, but they must be different, right? More robust.
Definitely. Soneto stressed this shift. Ingenuity was a high-risk technology demonstrator. It was okay if it failed early. These new sample recovery helicopters, they need to be Class B.
Class B. What does that mean in simple terms?
It basically means much higher reliability, no single-point failures. If one component breaks, there's a backup so the mission doesn't end. It's a much tougher standard.
So taking the Ingenuity design and making it more heavy-duty, more reliable?
Exactly. They're scaling it up, adding an arm to grab the sample tubes, even adding wheels to potentially reposition on the ground.
Wheels on a helicopter. Interesting.
Yeah. And crucially, Soneto said, the physics holds. Meaning the basic principles of how Ingenuity flew in that thin air, they work, and they can be scaled up confidently.
That's huge validation.
It really is. And think about all the specific tech Ingenuity proved. Using commercial, off-the-shelf parts like a cell phone processor and camera.
Stuff you wouldn't think would survive on Mars.
Right. But it worked. Plus, the lightweight structure, the flight software they developed called F-Prime, the guidance and navigation systems. All of it got 72 flights worth of real-world Martian testing. That data is priceless.
So it wasn't just that it flew, but how it flew and what components worked.
Precisely. That ground truth data is incredibly valuable for designing the next generation.
And it's not just these sample recovery choppers, is it? He mentioned something even bigger.
Yeah, he got pretty excited talking about the next step, this chopper team concept. Basically a large hexacopter, 6 rotors.
Bigger than Ingenuity, obviously.
Way bigger. He said potentially larger than the Perseverance rover itself.
Whoa. What could something like that do?
Carry a significant science payload, maybe around 5 kilos, and travel kilometers every single Martian day. Think about that compared to a rover's pace.
That's a game changer. You could cover so much more ground, access places rovers can't reach, like steep cliffs or canyons.
Exactly. It opens up the possibility of exploring, potentially, the entire planet from the air. A totally different way of doing Martian science.
Oh. Okay, so let's pull back a bit. We've gone from Hubble's weather reports to Ingenuity's incredible flight saga and now these future aerial explorers.
Yeah, it's quite a journey.
What are the sort of overarching takeaways about operating on Mars from Ingenuity's experience?
Well, clearly they learned a massive amount about flying in that low-density air. But also, thermal management was huge. Tseneto's pointed out most of Ingenuity's energy wasn't even used for flying.
Really? What for then?
Just surviving the night. Running
Yeah.
little strip heaters on the batteries to keep them from freezing. That took the bulk of the power.
Just staying alive was the main job.
Pretty much. And of course, the autonomous flight capability. Proving that could work reliably over 3 years is enormous for any future robotic exploration on Mars or elsewhere.
And all that data. 3 years worth.
An immense data set for engineers and scientists.
And looking at Mars, this cold, thin atmosphere world, and comparing it again to Venus, hot, thick atmosphere, acid rain, it really brings us back to Earth, doesn't it?
It really does. That point from the Danzoid video about Earth's greenhouse gases, CO2, water vapor, methane, keeping us in that sweet spot.
But also the danger of too much CO2 from, us, human activity.
Exactly. Seeing the extremes on Venus and Mars really underscores how critical Earth's atmospheric balance is. We're living on a knife edge in cosmic terms.
And this whole search isn't just Mars and Venus. Europa keeps popping up.
Right. That subsurface ocean is such a tantalizing target in the search for life beyond Earth. And the lessons we learn on Mars about robotics, autonomy, operating in harsh environments.
They'll help us figure out how to explore places like Europa someday.
You've got to think so. The technology, the operational experience, it all builds towards tackling those future, maybe even more challenging destinations.
Okay, so summing up this deep dive then. We've got Hubble showing us Mars is currently cooler and drier, Venus recovering from maybe volcanic outbursts,
Yeah.
stark differences.
A real-time snapshot of our neighbors.
Then the incredible story of Ingenuity. Just amazing engineering overcoming those massive Martian hurdles, thin air, cold autonomy, 72 flights.
A true pioneer, paving the way.
And paving the way quite literally with its lessons feeding directly into plans for sample return helicopters and even these huge future hexacopters. It's changing how we even think about exploring Mars.
Absolutely. It proved aerial exploration is viable and incredibly valuable.
So here's something to chew on, maybe, as we wrap up. We see how drastically different Earth, Venus, and Mars are now, even if they started similarly.
Right, those divergent paths.
What does Ingenuity's success, succeeding against the odds in such a harsh place like Mars, what does that suggest about life itself? Could life potentially adapt and find ways to exist in really unexpected, extreme places, like maybe, just maybe, in Europa's hidden ocean?
That's a fascinating question. Does the adaptability of our technology hint at the potential adaptability of life itself? It definitely makes you wonder about resilience, both in machines and maybe in biology, too.
Food for thought. And look, we've only really skimmed the surface here.
Oh, for sure. There's so much more detail in the sources.
Absolutely. So we definitely encourage everyone listening to check out the original stuff, that Danzoid video, the NASA Hubble article, and especially the full Small Steps, Giant Leaps podcast with Teddy Sinetos. It's really worth diving deeper.